Cool. Hi, everybody. How's it going? Have a good day? Good conference? Yeah? Is it your first time at Midwest JS? First timers? New to Minneapolis? Welcome. I don't live here. I live a little bit outside of town, but I like it here. All right, so this talk is JavaScript Forensics. And it's a talk about how it all goes wrong. How you've built an awesome web application and you've deployed it out to production and your customers are using it. And they click on that awesome button that you built for them and it doesn't work. And they keep clicking it and clicking it and clicking it and it doesn't work. And they're like, nuts to this, I'm going somewhere else. It's about diagnosing and debugging our production web applications. I'm Todd H. Gardner. This is what I look like on the internet. There's my Twitter. Feel free to hassle me there later. Tell me I'm wrong. I like that. Why is this important? Because everybody writes bad JavaScript. I write bad JavaScript. I write really bad JavaScript. People who are really, really smart write bad JavaScript that inevitably breaks for somebody. These are all really smart people working at really smart companies. And they get JavaScript errors. These guys, these people here, are working on some really amazing things, and yet it still fails for their customers. There's lots and lots of broken JavaScript on the web. Just yesterday, I put out a blog post where we analyzed all of the data that I capture from another thing that I build called Track.js, a JavaScript error monitoring service. And we analyzed all of our data across all of our customers. And last month, 40% of page views experienced a JavaScript error of some kind. 40%. 40% failure rate on average across hundreds and hundreds and hundreds of very big web properties. In a lot of ways, JavaScript on the web is still the Wild West. And as developers, we're just trying to ship software. We're just trying to get something out the door. And to do that, we have to deal with a bunch of challenges. We have a very treacherous landscape to deal with that has, there's a few browsers that all have a little bit different way they want to do things. And we use several third-party scripts to make things happen. Chances are, if you have a large-scale web application, you've probably brought in some JavaScript that you don't control. You brought in analytics services, social networks, transaction providers, Stripe, Twitter, Google Analytics, Mixpanel, something like that, to help you build what you're trying to get done. And there's lots of application frameworks that you add in on top of that to try and get it done. Every other day, a new JavaScript framework comes out claiming to fix the problems of the last. And then there's an army of JavaScript libraries of variable quality and support that we then add in on top of the mix. And so we have lots of different browsers, different frameworks, different third-party scripts, and different libraries that we're throwing out into the web environment where our end users will start using it with a browser that we might have never tested it on. Maybe they have browser toolbars or other invasive plugins that we have never tried or never supported. And so it's almost inevitable that our web applications are going to break. And so when they do, we need to have the tools to understand how it broke and how to fix it. So I want to show ending up in a disaster. I don't know why that guy's standing right there. That doesn't seem like a good idea. So I want to show you a product that I've been working on. I'm going to throw this one out into the Wild West. And this one's called Soliloquy. Now, Soliloquy I call the anti-social network. And it's kind of like Twitter. This is Soliloquy. And just like Twitter, you can share your status. You can type some interesting thing and add it to a timeline. You can look across your timeline at all of the other things that you've said. And also, just like Twitter, I have awesome inline ads. Because aren't the inline ads in Twitter amazing? But I have awesome advertisers like cats. Lots of cats. Bears. Bears advertise on Soliloquy. David Hasselhoff advertises on Soliloquy. But unlike Twitter, Soliloquy leaves out the most irritating part of social networks. Other people. Because with Soliloquy, it's all about you. That's right, you can only see your status updates. Other people's are entirely private to them. You can't see theirs, they can't see yours. And therefore, there's no nasty arguments on Twitter, or on Soliloquy, unlike Twitter. All right, but Soliloquy has a few problems. And so that's what we're going to dig into next. This is what we're going to use as our framework for debugging some common web application problems. And to do that, we're going to use another tool that I helped create called Track.js, which is a JavaScript error monitoring service. So we track when your production users actually encounter problems, we can capture those errors along with a bunch of context and bring it back. And so we're going to use some of that as part of debugging today. Soliloquy is being attacked by the 6 most common JavaScript problems of web applications. These 6 outlaws, we are going to go through one at a time, find them, understand them, and debug them. Sound good? I hope so, because that's what we're doing. All right, number 1, Jane Doe. Characteristics. This thing shows up as script error. How many of you have ever tried to deal with script error? Almost everybody. What's going wrong? I don't know. Where did it happen? I don't know. What file was it on? I still don't know. Script error. It blew up somewhere. Go find it. Go figure it out. Script error impacts every single browser, and it impacts a lot. So Soliloquy gets about 5,000 hits a week. And almost half of them are encountering this script error across all these major browsers. And this isn't just like IE8 blowing up. This is like new stuff blowing up. But I don't know what's going wrong. So let's dig into Soliloquy and see if we can figure out what exactly is happening. So if we just pop open the DevTools here, I'm going to be using the latest version of Chrome just because its DevTools are better. All right, so if we pop this open and take a look at our console, we see a couple of problems. Can anybody not see that? All right. So I have a couple of things going on here in console right away. The first thing you might notice is I just have a lot of console messages. This is my own kind of personal style. When I'm building web applications, I tend to write a lot of state change events into my browser console so that when I pick up an application, when I'm trying to debug it, I can see some context without having to put breakpoints all over my app. I feel like adding these sort of logging, debugging statements help me build better applications. Well, so I see a couple of errors here. The second one here is this uncaught reference error. The first one is what was actually recorded and sent to my server. What was recorded was script error, and then a bunch of really valuable context. Chrome doesn't have to obey the same rules as the rest of JavaScript, and so it's able to tell me what's really going on. But I only get to see this if I'm lucky enough to recreate it in my own browser. What gets recorded is just script error. Now, there's no real magic here to what I'm doing here with recorded, so I'd like to show you that here quick. All I'm doing here, highlighted too much. All I'm doing here is I'm attaching to window.onError. Window.onError is this common function that's been around since the very beginning of JavaScript. It's available in all browsers. And you can attach a function there, and anytime the browser doesn't know what to do with your error, it will pass some information to it. And so all I'm doing is I'm taking whatever gets passed, and I'm printing it out to console.error, the entirety of the arguments, everything that I know about that error, which in this case is nothing. I know that a script error happened. Well, so why is that happening? The real error here is in this sidebar ad provider. And so if we look at that, the sidebar ad provider, what's interesting about that isn't necessarily what the error is, but where it's coming from. the sidebar ad provider is being loaded from ads.local port 3000, whereas the rest of Soliloquy is being loaded from localhost 3000. Now this makes it a different domain and therefore a different origin. And so what we're running up against here is a violation of the same origin policy within the browser. Because an error came from a different origin than where your page was loaded from, the browser is trying to protect information leaking from between domains and obfuscates that error. It says, nope, I will not let this information pass through. It could contain something sensitive that I don't want the other party stealing. Well, that's all fine and good, but it really makes errors hard to troubleshoot. And so recently there have been some changes made to the spec that allow us to opt out of the same origin policy for this sort of thing. The first step is to, when we're serving these third-party things, we need to serve them with the CORS headers. If you're not familiar with the CORS headers, the cross-origin resource sharing, this is the same headers that allow us to make AJAX posts and gets to other domains. It's what's enabled a lot of modern single-page application development. If we look at how these things are being served, scripts, inline ad provider, headers, we can see these access control allow headers, access control allow origin headers. These are the cross-origin headers being served with it, saying that where these things are coming from, the provider of sidebar ad provider will allow us to opt out of the cross-origin or of the same origin policy. But now we need to teach our application to opt out of that same origin policy. And so we can do that with a minor change to our code. Here when we're referencing the scripts, which you'll notice all of my scripts are actually coming from different origins than the main application. I'm loading my libraries from cdn.soliloquy.local, and I'm loading some different advertising providers from ads.local. So in all of these cases, I need to tell the browser that I trust these domains. I want to get good information from these domains. And to do that, there is a new attribute on script tags called cross-origin. Cross-origin equals anonymous. By decorating your script tag with cross-origin, it instructs the browser to look for the CORS headers when making these requests. And if those CORS headers exist, it will no longer obfuscate errors. So with those in place, if we go ahead and just refresh this, we still have the error. We haven't actually fixed our bug. But the information that we capture about the bug is now real. We don't just see script error. We see the real message with a real file, a real line number, and real stack traces. We would now be able to actually debug and correlate these messages in some sort of logging statement. However, just a quick word of caution, something that I've personally run into recently. If you decorate these scripts with cross-origin, and those scripts are not served with the CORS headers, like you accidentally take them off of your CDN, or the third party that you're pulling them from stops offering them, you can come in if you want, or the provider stops offering them, Chrome and Firefox will just not load the script at all. The script will simply fail, which, as you can imagine, could cause quite a bit of disaster if you're trying to load Angular from a CDN offering CORS headers, and then it just doesn't load one day. So just a quick word of caution, this is a two-sided thing. You have to teach both the source offering the script as well as the application itself. This was script error. And the problem that we're addressing here is browser obfuscation due to the same origin policy. Anytime you are referencing a script from a third party, pulling something down off of Google CDN, referencing a third-party analytics script or tracking script or whatever, anytime you're putting something on an origin different from where the main page is coming from, the browsers will obfuscate error messages, and you'll need a way to get around that. So with that out of the way, we can start addressing real problems in our application. And so let's move on to Jane Doe. This is the error that we were seeing in the console a minute ago. Get random ads is not defined. And it seems to be impacting everybody. And it came on very suddenly. So we didn't do any major changes to Soliloquy lately. Soliloquy's been pretty stable for a couple of weeks. But yesterday, all of a sudden, we see a huge spike in errors. We're up 500%, and we're getting about 15 an hour, which isn't a lot, but Soliloquy's still growing. We're still a startup. We have a whole lot of errors that are happening, and we didn't change anything. So let's dig in and see if we can figure out what's going on. Well, so here's this get random ad is not defined. And like I was saying earlier, this is coming from an origin that we don't control. I pay some amount of money to the sidebar ad provider to give me this script and let me do stuff. But it's breaking, and it's breaking my page, and it's potentially impacting my customers. So let's see if we can figure out what exactly is happening. The Chrome DevTools have nicely highlighted exactly what's going wrong. It's saying, hey, you're calling this thing called getRandomAd, and it's not there. If we just look around here, we have this other function a little farther down called getRandomAds. So potentially this was just a careless developer who made a typo in the application and checked it in. The point with that is not that I never make typos, because I make typos all the time. The point is that this change that was not made by me, it was not made by my team, it did not go through my code review process, my release process, impacted my app. Whenever you're bringing in a third party, you are introducing risk into your application, the risk that they can break your site outside of your timetables. Maybe you don't even have a team working on this app anymore. Maybe it's in maintenance mode. Maybe you released it and the team has moved on to something else. The third parties can still break it and they can still take it down. Now that we've fixed our third-party script, we see we have a lot more ads because Soliloquy needs some more money if we're ever going to take off. So I've thrown a bunch more ads for cool things like bears and bacon and David Hasselhoff. And so hopefully we'll be able to build up some revenue and launch this soon. So third-party errors. These can cause uncontrolled changes in your application. You've introduced some script that gives you some functionality. You probably don't want to write a payment processor, and so you probably want to bring in Stripe, or Braintree, or PayPal, or somebody. At any rate, you want to bring in somebody else to handle this for you. They're giving you a ton of value, but they're also introducing risk in your application, that their development cycle, their developers, can break your application. All right, that was the major errors, or the global errors affecting us. So now we can start digging into some smaller things impacting Soliloquy. We have another Jane Doe. Cannot read property destroy of undefined. We start seeing this error coming up a little bit in our application. And what we see as we're tracing through is that we can correlate this error with other actions. I'm seeing that anytime we get this particular error, it's immediately preceded by the user clicking on that button. So that gives me a strong idea of where this error is and how to go about trying to recreate it. So I have a button called JS delete statement. Let's see if we can figure out where that is. So if we pop open the console, let's just see if we can find a thing called JS delete statement. Oh, is that not what it's called? Back. Maybe that's not what it's called. IntelliSense for the rescue. Oh, dang it. Nope. All right, it's this button right here. So this button right here, whenever a user is clicking on the trash can to delete one of their statements, we're creating an error. And I don't know why you would ever want to delete one of your statements, but whenever somebody is, we're encountering some problem. So let's see if we can recreate this. So let's try and delete my hello Midwest.js statement from earlier. Oh, all kinds of stuff blew up. All right, so when I clicked it, my application tried to delete this statement, and then we recorded an error. And this looks like the error that we were seeing in our dev tools. This cannot read property destroy of undefined on soliloquy min.js, line 1, column a whole lot, and a whole bunch of stuff. Now, that's a little bit different than what Chrome is telling me here. Because Chrome is telling me the same thing, that cannot read property destroy of undefined. But it's telling me it's on statement view.js, line 30. And that's pretty cool. But how does it figure that out? Because here it's coming from soliloquy min.js, line 1, column a lot. And this one is actually telling me something cool. Well, this is coming from source maps. As part of building the soliloquy.min.js file, I'm using uglify.js to concatenate and minify all of my stuff down into a single file, which is helpful and makes my application, makes Soliloquy faster to deliver because my customers have to download fewer bytes from fewer files. But what's hard is that error messages get gnarly. I see things like this when everything gets minified down. A draft spec that a lot of browsers and build engines are starting to build or use is called source maps, which is like taking a map between your original source files and pointing them to the location of your minified concatenated file. Chrome, if you actually have the dev tools open, will look to see if you've built source maps, which you can tell by looking at the source. It can tell by looking at the source of the script. Oop, I need to bring that up. You guys can't see that. Come on. Which you can tell by looking at the minified file itself and see that, hey, there's a source map here at this place. Chrome will go ahead and download that and apply those maps to any of the error message, any of the things that it's putting here into console. And so I can see that this is actually coming from statement view.js. Well, so now let's see if we can actually debug this and see what's going wrong. So if we pop open the stack trace, we see not much. We see that this thing blew up because an anonymous function on statement view.js line 30 blew up. That's not really helpful. It's kind of hard to understand what's going wrong. So another feature that Chrome has shipped probably in the last 9 months, but it's my favorite thing I think they've ever done, is this little checkbox right here. This is my favorite checkbox in the world. This little checkbox will turn on async stack traces in Chrome. So much of the JavaScript we write is async. The code that gets executed that creates an error probably wasn't started from the beginning of your application. It was probably started in response to a click event, a timeout event, an interval, an XHR finishing. Some event in your application triggered something to go wrong. But you don't know what started those things because they're happening asynchronously. They happened in an execution thread earlier in your application. By turning this on, Chrome will start listening to all of those asynchronous stuff. Let me show you. So we're going to refresh this and do the same thing. Notice the hello Midwest.js is still there. The delete did not work from the last time. But if we go ahead and do it again, and we pop open the stack trace, we see a lot more good stuff here. We see the same initial thing, the anonymous function on statement view.js line 30. But we see that that anonymous function was passed into a set timeout. And that set timeout was called by this thing on statement view.js line 30, this onDelete function, which was called by some jQuery blah, 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 stuff I don't really care about, other than it says something about events. And so this is probably something about binding up an event. So now we can actually dig in and with some insight about what's going wrong and how do we go about fixing it. So if we pop open the code, what might not be entirely obvious on the projector, it's not, There's a slightly different gradient of gray on these different lines, and that maps to how source maps came about. Not every line in this file can we put debug stuff on and inspect, because this is an interpreted file. This is what Chrome has tried to recreate from our original source files and the source map, but it's not what's actually running. And so you might experience some weirdness interacting with this file. But we can read it, and we can see what's going on. So here's the code in question. On delete, printing a console message, which I'm pretty sure we saw earlier. Passing into a set timeout, because apparently this needs to be deferred into a next execution cycle or something like that. And then we remove the view. But this has violated probably the most common JavaScript error ever. And that's this thing right here. There's a smell for you. You are using the word this. I am using the word, this is my code. I am using the word this inside of a callback function. And this is probably not what I think it is. When this callback function comes back, it's not in the same context that the file is in. If we open up the code, we can look at some ways we can fix this. Here we go. When this function gets called, the value of this will not be statement view, which the code is expecting. The value of this will just be the global object. And so in order for me to call this destroy method, which is what's blowing up, I need to attach context here. Now there's a couple of different ways to do it. Probably the most common would be var that equals this, or var self equals this, depending on which JavaScript programming book you read first. And then you could reference it like simply that.model.destroy. Something that might be a little bit more contextual, since we only really need it once, would be, say, something like var model equals this.model, and then simply say model.destroy would be pretty cool. Or if we want to be really cool and use like some newer JavaScript features, we could just bind what value of this we want it to be. So right here to the end of the function, we can just say bind this as a little bit of glue saying, hey, the value of this, I also want to be the value of this. And it attaches them together. Now, if you need to support older, less cool browsers that might not have that, don't fear. We have a solution for that as well, is we can use underscore or Lodash, whichever you prefer to say when you look at this character right here. Underscore dot bind this function to the value this, and that would be fully compatible doing the same thing. I personally think there's a little bit of readability problems with that as I look at that, and it's kind of crazy. So whether you want to use var that, var model, or binding the function, it's kind of up to you and your style. But with that in place, we should now be able to successfully delete functions, or delete our statements. Ooh, and they're really gone. And there's no errors. Context errors. This is still the most common JavaScript logical error that I see, and I see it in production apps all of the time, in obscure functions that might not get executed all the time, like deleting a statement. These things can be discovered through test. If you are being very thorough about testing your application before releasing it, you can discover all these. This isn't a production monitoring problem. However, JavaScript apps tend to be very large and very complicated. And so having monitoring in place can help you when your testing misses a problem. Another Jane Doe. A.text.substring is not a function. Now this is not a very common error. In fact, it only happened to one person. but it happened a lot. This one person just had a really, really, really bad time. In fact, they probably had such a bad time that they're going to like complain about Soliloquy on Twitter and like write nasty things about us and probably hurt our overall brand and keep us from being as successful as we could. So let's see if we can help this one poor person and figure out what's going wrong. So I tracked some information about what their customer ID was. And so we can go ahead and load up their data and see if we can understand what's going wrong. They happen to be customer 2. All right, so now if we load customer 2, this is what customer 2 sees, which isn't cool. They don't have a timeline. They don't have any inline ads. I do get to show them a lot of sidebar ads, though, so that's cool. I'm getting a lot of impressions there, making some money, but they're not really getting any value out of Soliloquy. If they type something here, it doesn't stay. Something else. They can post an update, and there's like, yay, it's working, and then they come back later, and it's gone, which isn't very cool. As we load the app, we can see the error in question. We tracked it with all of the good information because we'd fixed the cores issue from earlier. And we tracked an uncaught type error. a.text.substring is not a function. So let's expand on this and see if we can debug what's going wrong. And we have a ton of information in this stack trace. So we have, again, because we have source maps in place, we're able to see the real file and line numbers. We see an anonymous function on the statement model being passed into something with _map, being passed into something.parse, a bunch of stuff we don't care about, blah, 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 blah. Oh, look, an XML HTTP request. So we must be dealing above this line. We're dealing with the results of an XML HTTP request. And below this line, we're probably setting up the XML HTTP request. Blah, 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 a bunch of code that's not mine, DOM content loaded. Something about the start of this application sends off an AJAX call. When that AJAX call comes back, we land here into this anonymous function inside of my function called parse here on statement model, and it blows up. Well, so now let's go and take a look at statement model and see if we can understand what's happening. Chrome, again, is being very nice and telling me exactly the part that failed. A.text.substring was not a function. Well, there's a bunch of expectations here. So we're obviously parsing a AJAX response body. You can tell the variable is called response. It's being called in response to it. We're probably iterating over some objectified JSON response body. And the expectations here are that response is something we can iterate over. We're passing it directly into _.map. And the thing that we're iterating over is an object itself with a property called text. We're also expecting text to be a string because we are, in Twitter-esque fashion, limiting the size of that string before we display it to 140 characters because we can't have an intelligent thought larger than 140 characters. So we're just truncating it right here. But this is failing. And I bet it's failing because of one of the expectations. So let's take a look at the data that's actually coming down here. If we go into the XHR, here at the beginning of our app, because we know this is responding to, or this is something fired in response to DOM content loaded, there's 2 different XHRs made immediately by my code. One to go and get the profile, and one to get a list of statements. The profile is just a single object. This doesn't look like the kind of thing we would be iterating over. So it's probably the list of statements. And here we have the list of statements. It is something that we can iterate over. So passing it into map feels appropriate. And the things that are inside of it are objects. And they do have a property called text. But the value of text is not a string. It's a number. And so we can't call substring on a number. That's why it's blowing up. If we go and take a look at the code right here, when we're iterating over this, text is a number, and we're trying to call substring on a number, and that's what's blowing up. And so at some point between when I wrote this code and when this user started using it, the expectations of that API changed. Either because I let crappy data in, and somehow I inadvertently saved a number into some sort of data store that would be flexible enough for me to change types, or the back end that I'm interacting with might be a third party, it might be a different team, it might be the API team inside my organization went and changed the API on me without telling me. So we need to be a little bit smarter about how we're dealing with this, because we have some expectations that are being violated here. So if we can be smarter about this, response could really be a lot of things. Underscore.map is pretty tolerant of what you would pass into it. And if it's something it can't iterate over, it'll probably just not iterate over it. But when we get in here, we need to be smart about what item is, because item could be a lot of different things. So if item is a falsy value, we probably just want to return and not do anything. But we probably want to log it so that we know we have some bad data. Well, what else could go wrong? If item.text, it might not be a thing, or it might not be a string. And if it's not a thing and it's not a string, then we probably want to also warn on that data so we can log some information. But we might be able to get away with something, because if item.text.toString is a thing, then we could make it a string. I know there's an error in this, don't worry about it. Item.text.toString.substring 0140. Else. And that is some really terrible code that I wrote in front of an audience. But what that should be able to do, I hope, is fix this poor user's problem and render their data. Even though we got an invalid set of data from this customer's account, I can still try and show them a better experience. I'm still trying to show them an approximation of the data they entered. And so I'm printing out the 42. Now, I have a lot of warnings that would go into my logging. We have a lot of bad data coming in here. And so we haven't solved the root issue. But the root issue is either with validating the data or with a change in our API. And so we need to take that offline and work with our back-end team to figure out how to make that better. This was an error in our data contract. Our web applications are rarely running in isolation. We're usually interacting with one or more APIs, and we have expectations about those APIs. When those expectations change, our applications can break sometime catastrophically. The more teams, the more different sets of people you have involved, the larger this problem is, and it's difficult to test for. You just need to make sure that you are controlling changes and that you can be as tolerant as possible to different data types as you are working, as you are dealing with these different APIs. All right, another John Doe. Inline adds is not a function. Now this is not a very common problem. Soliloquy is getting thousands of hits a week. We only had this happen 134 times. But it didn't happen to just one person. This is happening to a lot of different people. 129 people experienced this error 134 times. And I don't really know where to start with that, because a.inline ads, this is another one of my third-party things. I'm loading this inline ads provider to place my awesome ads for David Hasselhoff kind of in my timeline. And how could that not be a function? Like, the app seems to work. Oh, let's go back to our default customer. Customer 1. I don't seem to experience that error. It works on my machine. So how could inline ads not be a function? If we look through our code, we can search for inline ads, which is what I'm doing here at the bottom, so everybody can see. And we can find it in a few different places. It's in inline ad provider, where inline ads is being defined, and it's being used in my main file, soliloquy.js, where I call it as a function. I call it as a function. This is the SDK that my third-party ad provider gave to me, to say, hey, we'll drop this function onto window called inline ads. You call it with your key and some options about how you want your ads displayed, and we'll take it from there. And this is where it's getting called. But I don't understand how it could not be there. Inline ads is being referenced in my main index file from inline ad provider. It's being placed on the page. And the soliloquy.js file is waiting for page ready before it does anything. So how could inline ad provider not be there? Well, we could simulate this and see if this was the cause of our error. I'll just comment out the script tag that loads it. And there's our error. That's exactly what we were recording. A.inline ads is not a function. So how could 134 times this have happened? Nobody's going into my code and just commenting out this file. Well, so this was probably one of the things that surprised me the most looking into real production error data. Sometimes script tags fail. Sometimes the network the device is on fails for one script. Not even your whole app. One script fails to load. The user is using your app on a mobile device, and they're on a train, and they skip from one tower to the next. And as they're doing it, a momentary DNS lookup for that third-party CDN fails, and that script dies. And your app is left loaded. To the end user, your app looks like it's totally there, except Stripe failed to load, or except Angular failed to load, except one of your scripts just isn't there. What is the behavior of your app if one of your scripts fails? It's not a very common situation, but it's inevitable once you get to a large enough user base. A little anecdote. In an early version, this issue has long since been fixed for us, but in an earlier version of Track.js, we would take payment via Stripe. One of the integration methods of Stripe was you decorate a form. So we had a form that took your credit card number and the expiration date and the CV2 number and all that stuff. And we would decorate it and say, hey, Stripe, grab these values when the user hits submit and send them off to the Stripe server. And then we'll come back and we'll get a token, and we'll use that token to validate. But if the Stripe script just didn't load, as it did for one very generous user in Australia who told us about this problem, if the script just fails to load, what would happen was they would type in their credit card number and hit submit, and it would shoot that credit card number right into our servers, violating all kinds of bad PCI things, and we had their credit card number in our server. And they saw it. They saw this thing happening, and they told us about it. And so we fixed it. But how often could that be happening in your app, and you just don't know about it? Because one script just doesn't load. So how could we prevent against this? For Soliloquy, this is a relatively minor thing. The impact of inline ads not being a function is pretty catastrophic to the user who experiences it, is they see nothing at all. They don't see their statements. They don't see their inline ads. They don't even see the sidebar ads. which are totally unrelated. But due to how my code is structured, here in Soliloquy.js where I'm calling inline adds, I'm calling inline adds before I call sidebar adds. And I'm setting up adds before I even go and fetch everybody's statements. And so when inline adds fails, everything downstream in this function fails. The whole thing blows up and nothing works. So I can address this problem with a real simple check of just saying, hey, is inline adds a thing before I try to use it? So if window.inlineAdds, go ahead and do inline adds. If there's no inline adds, we should probably say console.warn inline adds failed again. Call them and complain. 3 months. So now, even when inline adds fails to load due to a DNS blip or an SSL handshake or whatever might be the thing holding up that one connection, the rest of my app can continue to function. Loading errors. This occurs way more commonly than I ever imagined. It's frequently associated with mobile devices or poor network connections, and something fails when referencing it. It's usually happening when you're loading a script from some other domain where there's overhead. Your browser has to do a DNS lookup to that domain. It's got to attach to that domain. It might have to do an SSL handshake to that domain, and then download the script. And if any of those things fail, you could get a failure in just part of your application. And in a way, those partial failures are more dangerous than a complete failure. A complete failure, you usually get like just your generic error message on your app, or the JavaScript is required screen on your app, or whatever you might have. Hopefully you've progressively enhanced and there's no problem at all. But what happens when just one fails? In our case, it was pretty catastrophic. All right, this is the last error I'm going to share with you today. Jane Doe. Slowing performance. Now, I had a customer complaining about Soliloquy on Twitter, and they were an author. They used Soliloquy to like type up their book notes all day while they're in a noisy coffee shop. And they were saying that I kept using it over and over the course of the day, it kept getting slower and slower and slower until eventually my browser kept crashing. And for them, this was totally catastrophic. The problem with this kind of error is that there is no good way to capture it programmatically, at least that we've discovered yet. Because when the browser crashes, it's the runtime itself that's crashing. When Windows goes blue screen of death, it can't like quick phone Microsoft and tell them why before it does it. It just crashes and does a core dump. And so we still have to rely on people who are generous enough to actually call us, tell us, complain on Twitter, whatever, when these sort of things happen. But so they did, and we heard a few things. We heard that as they were using Soliloquy, it would get slower and then eventually crash. So that sounds kind of like a memory leak. So let's see if we can troubleshoot a memory leak here in Soliloquy. There's a couple of different ways you can do this in Chrome. My favorite is the timeline. And so that's what we're going to kind of play with today. So the timeline shows you a couple of different things. It can show you how much JavaScript memory is being executed, how much time is spent, how many resources are being allocated over time on different kinds of activity. So what I'm going to do here is I'm going to begin interacting, or I'm going to start recording with my timeline here. And then I'm going to do a few actions in the timeline, or I'm going to do a few actions in Soliloquy that change its state. And then I'm going to reverse them. I'm going to delete the statements I create, hopefully bringing the end result back to 0. Because the DOM should look the same, the event should look the same, everything should look the same at the end. So I'm going to go ahead and I'm going to say, hey, Midwest JS again. Another cool statement. I don't know, something else. Oh, I'm not even recording. Why didn't you guys stop me? Stop. All right. Record. 1, I don't have any more ideas to be clever. 2, 3, delete, delete, delete. All right. So now here is all of the activity that the timeline captured while I was doing that. And it's kind of crazy. There's all kinds of stuff here, and it's kind of hard to know where to start. So here's where we're going to start. Focus down here first. These are the graphs of what's going on in the used amount of JS memory. Let me expand this so you can read it. Blue is in the JavaScript memory. I don't do anything with documents here. Green is the number of nodes, the number of different elements in the page. And yellow, golden, is the number of JavaScript listeners. How many times are we listening to different events to happen? And so there is some stuff going on. Like we see here in the number of nodes, we see a big increase happening here, then kind of leveling off. But then we have another step going up. And it just kind of keeps going up and up and up. We have a similar pattern here in this used JavaScript heap. As we peak somewhere around here, I wonder if this might be like when I refresh the browser, because that seems weird. Here, as we're adding more stuff to the page, we go up and up and up. Something clears, but we start going up again. We're definitely not ending at the same place we're starting. So we can start digging in to understand more of what's going on. And this is why I like doing this, because it's just like a video game. So if anybody used to play like first-person shooters, spent a lot of time in beta Counter-Strike when I was younger, you can use just the classic WASD keys and just start zooming in here. I'm going to slide that down a little bit, slide this down a little bit so we can see. And we can just start zooming in on different things to see what exactly is going on. So I'm zooming in here on this step to see what's happening. And the closer I get, the more we see that this isn't one thing. It's not one event that just allocates a ton of stuff. It's a bunch of little things that kind of happen in rapid succession. And we can go in here, and the closer we get, the more we can see about it. So we can see that all of these little steps, all these little increases in the JavaScript memory are being fired in response to this timer. We have a timer going off 4, 5, 6, 7 times, 8 more times. And it's being triggered into this function here in the sidebar add provider. All of those functions are in response to this XHR ready state change, where it looks like we're fetching an add. And then each time we do this, we are increasing the amount of memory happening. So it looks like there is some allocation repeatedly going on right here in the sidebar add provider. And so we can navigate right from here. And we can go into this sidebar add provider and take a look at what's happening. In this particular case, we see the interval. So we saw the interval happening in our timeline. And on this interval, which is probably like an advertisement refreshment interval, we're looking at the advertising container and we're clearing it out. We're just zeroing out whatever's in there. Then we go and we get some ads, and we place those ads in the container. So we place the ad by doing an AJAX to say, hey, go and get me the context of this, or the contents of this ad from its URL. And when we get the ad, we stick the text of the ad inside of the element, and we attach a click handler to it. Because the advertising provider probably wants to track clicks on their ads so they can bill people and generate metrics and all kinds of other cool stuff. And so we've attached an event to the text that was dynamically inserted into the element. And that element gets cleared on this interval. At no point is that click handler detached. Because I've attached a click handler to this element, that element is still around. It's not in the DOM anymore, but it's still around, floating off in memory space. If we zoom back out, where is it? There we go. If we zoom back out, we can see here's one big allocation of JavaScript memory handling all of that logic. and zoom out further, we can see another allocation of that, probably right here. If I can zoom in, come on. Where is it? We can see another allocation of the ad provider doing it again. So every few seconds, that interval is going off, and it's refreshing all of these ads and attaching click handlers to them. And then the interval comes again, and all of those ads are just thrown out. But the click handlers are all listening to them. They're still waiting for somebody to click on that ad that's no longer visible to the user. And all of the memory associated with the closure that that ad is in is still being retained. And so another way to think about that is these writers who are using Soliloquy all day long, after a few hours, they have literally thousands of David Hasselhoffs floating around their page, just waiting for you to click on them. This is leaky memory, and the biggest culprit here is detaching elements. Anytime you are dynamically rendering elements and attaching click events to them, you have the chance that this can happen, where you've attached some logic to some sort of event on an element that gets pulled back out of the DOM. And when they get pulled back out of the DOM, you probably don't care what things happen to them anymore, and you need to be able to detach from them. There's no good way to really monitor for this, as I said before, other than just periodically playing with your app. Open it up, click through, play with the timeline, see if you have memory leaks in your application. So this was JavaScript Forensics, and the 6 most common errors. Script error is the first one. It obfuscates all the other ones. It hides the real data if you try and monitor for them. Third-party errors. Anytime you're introducing a third-party script into your application, you're introducing risk that they can break it without your changes, without your knowledge. Context errors. The most common logical error in JavaScript, when you misunderstand the value of this when a callback function is coming back. Data errors. You've bound to some sort of third-party API, and you have expectations about the shape, and that shape changes. Loading errors. When part of your application could fail to load, what state is it left in for the end user, and could it potentially create all kinds of vulnerable data for you? And finally, memory errors. Memory leaks in JavaScript due to detaching elements that can cause the browsers to slow down, and eventually crash. Or worse, cause the fan on your MacBook to spin up so loud that everybody else in the coffee shop just stares at you. If you're looking for some help to detect these kind of problems, you should take a look at Track.js. It's a JavaScript error monitoring tool that I helped build. We do all kinds of cool things to tell you about what are the kinds of errors that you should care about. We trend the errors to tell you, here's the things that are happening the most. We took some inspiration from like music top 40 charts. Here's the top messages that are happening right now, the gainers and the losers. And for an individual error, we captured tons of context about what the user actually was doing. I can tell you what kind of AJAX events were happening, what was the user clicking on, what kind of inputs were they entering, all is the context leading up to how the user got into a bad state. So if your Wild West application needs a new sheriff, I might be able to help. I'm Todd Gardner. This was JavaScript Forensics. Thank you.